Welcome to the Øredev keynote chats for 2025. I'm Frederick, and as usual, we're publishing our keynote speaker chats from the conference as short episodes. This year, we're releasing all 6 at once, Netflix season style. Also, as usual, links to each keynote and all other relevant information can be found in the show notes. They are in your podcast player right now, or at kodsnack.se, Kodsnack. Now, it's time for Justyna Zander to discuss self-driving vehicles and the state of tech in that area. In our keynote, she talked about how technologies bundled under the AI label, including some generative aspects, are used to improve self-driving and what the current state is. And Justyna really knows her stuff. She has worked in places like NVIDIA and Ford. She has a PhD and a mile-long list of merits and publications. And our discussion spun out from the keynote, starting with how to build what's called emotional intelligence into self-driving cars. Enjoy. Thank you for a great keynote.
It's been a pleasure.
Yeah.
Did you enjoy it?
Yeah, I made a few notes. We'll see where we end up.
The main goal was that you learn something new.
Yeah, and
it advances you.
I dare say you accomplished that for everyone. So I was curious, when you show these setups with emotional intelligence and
yes,
adding on more stuff around, I guess what I think of as the AI things we have today, it's like, which parts of these do we know how to build already? Which parts remain to be figured out?
So we had those four types in the box.
Yeah.
Emotional intelligence is generally composed of self-awareness, self-regulation, motivation and intent, social skills and empathy.
Yeah.
The self-awareness could be mapped to perception. So basically, the neural networks that are responsible to observe the world, and deep learning contributed to that one a lot, are the representation of self-awareness.
Yeah, so that one we kind of have.
We have it in the spatial sense,
but
we don't necessarily have it in a different dimension. You could argue that in the intelligence, the more context we're going to be able to process, the more this context is going to contribute to self-awareness.
Yeah.
But that context is basically, one, processing the context, so the number of tokens that we talked. Two, the memory, how well it's going to remember the self-awareness context.
Yeah.
And how well it's going to be able to self-regulate, which is the second component, based on that context.
Yeah.
And the self-regulation is the next one. So basically, it's the policy of the machine.
Yeah.
With the policy, when self-awareness is the understanding of the machine where it is, the self-regulation is understanding where to go next.
Yeah.
And then you have those two remaining boxes, which are 3 components: motivation and intent.
Yeah.
Motivation is very much related to human agency. Basically, what did the human tell me to do?
Yeah.
And that overall goal of a human should always be like number one for the machine to be able to accomplish.
Yeah.
And then the machine can break it down to multiple steps and sub-goals. But the human agency should be the first one.
Yeah.
It's not always the case, like I said in the talk.
Yeah.
But we should be striving for it to be the case.
Yeah. Yeah, exactly. What would the human want?
Yeah.
Make that happen.
And then the last one, and maybe the most difficult one, is the social skills and the empathy.
Yeah.
Because how do you teach the machine empathy?
Yeah, exactly. Do we have any idea about that, or is that still open?
Well, we had this talk yesterday about neurodiversity. And there are people that don't necessarily understand empathy the way other people do, but they can be taught what are the reactions to various actions.
Yeah.
And if you teach the machine about the action and reaction, that is somewhat in the social skill environment, then the machine may know. That's basically the context the machine is going to have.
Yeah. And teaching is, in this case, is it a matter of doing the same kind of training as we're doing for neural networks now, or is it something different?
No. The teaching is basically teaching the AI.
Yeah.
So anything that you can leverage to teach the AI, it could be the right data set, It could be the right behavior, let's say in a video, that the machine is able to interpret. It could even be a narration, some kind of like storytelling to teach the machine, and the machine is going to derive or infer from the story.
So this part is we kind of have an idea about how to do that, or...
Well, I have less idea because I'm in physical AI space, but I'm sure there's a lot of researchers who are working on just exactly this and spending decades.
I just think it's interesting to try and get a feel as an outsider for which parts do we have a good idea about, and which parts are we still like exploring.
Well, the thing about other fields is that, as you know, software developers were the first to be disrupted because software developers are using AI every single day. It's the first target group, just naturally. And then after software developers, you have the roboticists, another natural group. And then medicine, biotechnology, healthcare, all those various types of specialists, they were not trained in AI or in software. So it takes a little bit of time for those two to converge. I think the future of education has to account for basically leveraging AI to augment humans in every of these fields.
So do you feel like things are moving fast or slow? Like, are you...
To me, very, very fast. The past 2 years, it's incredible pace, basically non-stop 24 hours 7. So that I cannot really sleep well. I don't sleep well the past 2 years. Just because something is going on non-stop. And you as a human, you are not able to catch up on everything because it goes in parallel. Basically, the body of knowledge about AI is like a gigantic GPU that never stops. How can I compete with that?
I think it's so interesting to hear from different perspectives. Because in some ways I can feel like on the, I don't know, sort of general individual consumer side, it feels like not all that much has happened. I don't see that many differences. I mean, we had the ChatGPT moment, and then we had, we have generative AI for coding and stuff like that, but it feels like it's still kind of similar.
I hear you.
I mean, few things are improving here, but it's not a dramatic change in that way. So it's fun to hear from other perspectives.
Yeah, so the comparison could be maybe comparison to science in general. When you are a typical human being who is not necessarily in those fields, the way you think about any technology is from the consumer perspective. And as a consumer, we use the phones and laptops. Maybe we use some of the LLMs or agents to improve or augment our daily job at work. And that's about it. But it does not mean that science is not going.
No, exactly.
And the same with AI. It doesn't mean AI is not going. We just don't see it. Enterprises see it. So if you look at for example, the hyperscalers, so companies like Google, Microsoft, Oracle, even Snowflake, this type of companies, they keep innovating with AI on such a pace that they basically replace the previous set of data centers they were based on with accelerated data centers as we speak, all of them. And what it enables them to do is basically to redo the search engine, redo the way we used to search for information. We now basically generate information as opposed to retrieve them. That's one example. And as a consumer, you maybe don't even notice. Like you go to the search engine and you're asking Google for some information. It generates this information first before it gives you links to the search. But you don't notice. You got an answer, so you don't really care that much.
And also on the sort of, as a consumer, you see all these negative things as well, like Microsoft is like pushing generative AI into everything, and you get all these headlines. You get the Gemini summaries in Google, and all the ones that are wrong, making stuff up, they get the big headlines, and you get the feeling like, oh, these big companies, they're just creating dumb stuff. Or why aren't they doing something important instead? I think there's a sort of a perception thing there as well.
Well, that's the reason for this is because it's really up to the leaders and really globally. how are we going to leverage the technology to improve?
Yeah.
And very frequently it happens so that we improve the return, not necessarily return of investment, the profits. And if the profit is number one criterion that drives your business, then you're going to have more deep fakes. You're going to have recommendation systems that recommend maybe more expensive things to buy.
Yeah.
And or agents that are enabling you to immediately buy, like one button click.
That's really good.
That's the unfortunate thing of capitalism, basically profit-driven.
Yeah, exactly. Because that was one thing I was wondering about as well, or the skeptical part of me.
Yeah.
Like all these good things that should be built into these systems, especially when you talked about empathy and such. And my cynical side is like, these big companies, are they really motivated enough to do the good parts, or will they just focus on the wrong pieces?
So let's go for a moment to Tesla, that I know is very controversial. But Ashok from Tesla was giving a speech just a few months ago about the intent of driving. So the intent of teaching the self-driving algorithm to become better. And what he noticed, and I think it was very insightful notice, that when humans drive in the rainy situation and you have a lot of rain on the road, you don't want to go through this rain. You actually want to go such that you kind of don't drive directly into the biggest rain pothole, and you rather go around it. Yeah. And so he said that the way they trained the systems was they were observing people in the rain. Yeah. And so they improved the way the robotaxi was able to go around. Yeah. Because humans don't want to be in that pothole. That's as simple as that.
It feels dangerous.
So that goes back to the motivation and intent box, where the intent of a human was actually preserved. Yeah. So coming back to empathy, the robotaxi was basically programmed to understand what the human wants. Yeah. And so I like that. There were other things where Tesla was able to watch out at the animals crossing the street and basically stop in front of the animals. I think it's not only cute, but it's also very useful if you know how to build this technology and how to continue that feedback loop so that you don't lose that empathetic view. Yeah. Even though you know that the system does not know, but you know. Yeah. And there is still this human agency at the top of building anything. Yeah. It's not just engineering, it's engineering with purpose. Yeah. What we are striving for.
Yeah, that's what we need.
Yeah, and look at that, Tesla does that. Well, if Tesla can do it, everybody can.
Yeah, I guess we just don't hear enough about it.
Yeah.
or something like that.
Yeah.
And so, I was curious about also these world models that you mentioned. What are they essentially? I mean, do you generate some kind of 3D world, or what's sort of the output?
Yeah. So the easiest way to understand the word model, I'm going to explain it as if we were 6 years old.
Yeah, that's perfect.
So basically, the word model is a spatial representation of a 3D reality around you. Yeah. And what is so special about this word model, because we used to have word model in gaming, for example.
Yeah.
You know, many people play games for decades, and many software engineers enjoy gaming. What is different now is that you can actually deploy AI to build generative word model as you speak. So basically, we are sitting here, and we have an alternate digital twin where we can say, make this environment as if we were sitting at the top of Mount Everest. And the generative word model is going to be able to create it on the spot and basically kind of put it together with the right means in a digital sense. Yeah. And so digitally we can see that. And not only digitally, if we embed it, so if we embed that scene in the right simulation tool, and the simulation tool is running on the physics, so basically it has gravity and forces embedded into it, then it's not only that you and I are going to sit on that Mount Everest, but we also are going to be exposed to the wind, and the wind is going to blow into our faces, and all of a sudden our hair is going to be messed up. So the generative skill of the AI is creating those word models much more representative than they used to be in the gaming industry of the past.
Yeah. And you can create many more different ones much quicker than, I guess, as well.
Basically in parallel, like the GPU. Yeah. Basically non-stop going. The moment you change a feature, you say, okay, now we are not on Mount Everest.
Yeah.
And basically...
See how it goes.
Right, so move us, almost like take us away from Mount Everest and put us on a sunny beach in California because we're now cold. We don't want that wind, maybe a breeze with the waves.
I'm thinking of it as some kind of really high fidelity, I don't know, almost unit testing or something. Okay, we have this, we're training this model. Let's first we put it in Mount Everest, see what happens to the car, and then we switch over to something else. Now we're in the desert, see what happens. And
you got it. You see, you think like an engineer now. So basically, you're moving from one scenario to another with different behaviors in that scenario. On Mount Everest, we had the cold wind, and at the beach, we have just the breeze, and maybe we watch the surfers.
Yeah, but there was there some kind of component of generative AI inside the emotional intelligence section and stuff as well? Where did it fit in there?
Motion intelligence?
Yeah, because there was a bunch done by neural networks, right? But there was something about generative involved as well. Or am I mixing it up?
Yeah. There is. So when I was talking about the autonomous driving neural network, and I said it's just, you could simplify it to just one network. Yeah. It's a little bit more, but let's say it's one network with that transformer architecture in it. The transformer is going to pay attention to the data that you were collecting and they were incoming about certain behavior on the road. For example, go from A to B such that you're going to turn right, turn left. You're going to be enabled to do those maneuvers and change lanes. And so if you teach your neural network that you are allowed to perform those maneuvers, the neural network, the emotional intelligence of neural network is going to decide when the next maneuver is the most appropriate and what is the next maneuver. So this is where the emotional intelligence is coming, because it's not only just the policy that it's going to create, it's also going to take action based on that policy that it's generating on the fly. That's why you need
that's where the generation comes in.
Yes. That's why you need that inference compute that as strong as possible.
Yeah, that's the place you can actually use more compute right now.
Because it keeps generating. It's basically you can feel like it's reasoning. It's in a sense it's thinking what's the next maneuver and how to take action to perform that maneuver.
Yeah. It's a fascinating area, seeing where it goes as well. And I don't know if I'm weird, but I feel happy that we're starting to talk about neural networks and more specific components again, rather than just labeling everything AI. Because I think the term AI is a bit overused, isn't it, in a way?
I'm not sure, because the circles where basically everybody is in that field, engineering-wise and science-wise. So maybe it's not overused in that sense. Is it overused? I don't know. AI, in a sense, you could see it as statistics on steroids. Yeah,
sure. Absolutely. I'm just thinking, like as an end user, when I see AI, I'm just as likely to think of Google Gemini telling you to put rocks on pizza as I am a self-driving car, and it doesn't really help me to mix those in the same label.
I see what you're saying. Yeah, so as a consumer, you might be overwhelmed.
Something like that. There is a use in more specific terms.
There is discussion about the internet versus the AI boom. Yeah. Or some say bubble. Yeah. Well, so I don't remember how it used to be in 1996 with the internet at the very beginning, because maybe I was a little bit too young to understand the impact. But the way internet was conceived was it was being built before the applications had a chance to become consumer relevant. And in a sense, we build a lot of infrastructure of the fiber for the internet ahead of the applications. Applications era started a little bit later, maybe 5 years later.
Yeah.
With the AI, it's the opposite. We do have applications already. The world of applications, as you know, exists and is really all over the place in digital world and even in physical world. In every user interface, you basically access the applications. So all these applications can be accelerated by the leverage of AI. Now, the leverage of AI does not necessarily mean it's just something that you as a consumer are going to understand. No. You don't need to know.
No, exactly. If it works well, I shouldn't care that it's AI behind it.
Correct. It should be embedded in the design of the system such that the application that we used to have is growing, is much faster, it's much smoother, it's much way less expensive to run, it's much less expensive for you as a consumer. That should be your criterion that you judge. If it is 10 times less expensive, that means AI augmented it. You know what I'm saying?
That's much better. And I mean, that's also something I look forward to when the bubble part of the bubble is sort of past and people just start talking about useful things again instead of like Microsoft slapping Copilot and everything. That part doesn't help me. I want to hear about the actual meaningful stuff.
The meaning for you as a consumer is your profit. So return of investment from their AI on your wallet.
But also, and also knowing that people are, working on emotional intelligence for autonomous vehicles. That things are actually moving ahead, and if it works well, it's going to make a big impact over time. And I want to know about those things because I can see the motivation for all the money being spent there. I don't see that motivation when Microsoft talks about Copilot because that's you spent all the money on this.
Exactly. Yeah.
And that's sort of a bad distraction.
I see what you're saying. So what was interesting to me last year was that the Nobel Prize laureates were mostly from industry, except medicine maybe. And one of them was the DeepMind Demis Hassabis with the protein folding. Yeah. Another was, Jeff Hinton is maybe between academia and industry, but there were more. And what they were able to prove with the AI that they contributed to build was that it is going to affect the health, the healthcare, the longevity of humanity. And I think these are the contributions that we should focus on and talk about more in terms of what is the actual use of
exactly.
AI.
Yeah, it's much better.
So they were able to recognize it in the Nobel Prize Committee.
Yeah. And it's fun that Demis Hassabis came up. He came up in the gaming industry as well, so that feels like a nice connection to me too.
Yes.
Is there anything you would like, anything more we should discuss that we haven't discussed yet?
See, I had my brain running since last night about what is the take-home message. Maybe the message of hope. The message of hope in the sense of I'm a very much technological optimist. I believe in the abundance of goods and services, given that the technology is going to be built with purpose. And it's up to us, and I believe in human. I actually believe in human potential so much, more than in anything else. So we can build it. We can do it. Maybe more on a personal note, like in life, I would say I'm more like a realist. I'm not so optimistic.
Okay.
And very much because of what's going on in the world today and how the world is shaping. But, don't let the noise of today demolish the positive signal of the future. The signal is definitely positive. And you don't have to be an optimist to see the positive signals. Try to run through the signals as opposed to focusing on the noise.
I like that very much. Thank you so much.
Thank you.
Big thanks for listening to Kodsnack. If you want to support us, leave a review in your podcast player of choice, or just tell someone who might like the podcast about an episode. And don't forget you can come hang out in our Slack channel. A link is in the sidebar right on our website at kodsnack.se. Once again, big thanks for listening. Talk to you later.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9,000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.